Hello everyone, this is Chinchark with another video walkthrough for week 10, question 2, Chaotic Santa. So this problem looks at a delivery guy who is out delivering end packages to end customers. And not only does he hand a random package to each customer, he opens the package before delivering it with probability 1/2. And so the question asks us, what is the expected number of customers that get their own package unopened? Okay, so first we want to break this down. So right now we're dealing with a very incompetent package delivery person, presumably Santa. And there are two elements to what's going on here. So the first part of this is that this delivery person is handing out the package at random. So that's one element. And he also opens the package before delivering it. So those are two aspects to keep in mind. And actually, I'll go ahead and just highlight them. And so we're asked for the expected number of customers to get their own package unopened. So this deals with expected value, but the first thing that we need before actually finding the expected value of something is to define what that is. And we need to define essentially a random variable that we'd be taking the expected value of. And so in this situation, you might think for a bit and come to the realization that each individual person is probably a great place to start off with. And so we're going to look at this sort of indicator random variable. And what that essentially means is it's kind of like a Bernoulli random variable. And so we'll call this C sub I random variable that has the value 1 if customer I receives their package unopened, and 0 otherwise. Pretty simple. So this C sub I is the same random variable, identically distributed over all of the different customers. So this is our definition of the random variable. And what we want to do is find the expected value of C, where C is just the sum of all of these individual indicator variables, right? Because if you take the sum of them, then you actually get the number of customers who got their own package unopened. And that's the beauty of indicator variables. So whenever you see this kind of structure, try to think of, an individual component that is identical across different individuals. That's usually a good sign that you should use an indicator variable. Okay, well, by linearity, we know that the expected value of a sum of random variables is just the sum of the expected values of the individual random variables. And so all that is left to find is what is the expected value for an individual C sub I. And for this, we kind of go back to the definition of expected value. I don't like typically to memorize definitions, but rather to come at them through logical means. And I always remember expected value in terms of value times probability. And so really, expected value is nothing more than a weighted average of values weighted by probability. So in this case, what does that mean? Well, we look first at what is the value of this random variable for each individual customer. Well, it's 1. And what is the probability that C sub I is equal to 1? Or in other words, what is the probability that customer I receives their package unopened? Okay, well, there are two elements to this, right? we'll write this here separately. The first element is that this delivery guy hands the package out at random. So the likelihood that it falls into the lap of the correct person is 1 over n. That's first. Well, we realize the fact that a person opens the package or not is independent to whether or not this person is chosen for this package. And this happens with 1/2 probability. So we can just multiply the two because they're independent. And so we get a probability of 1 over 2n. And so this summation looks like this. And we know that I goes from 1 to n. And thus, your expected value is none other than 1/2.